All right, Algebra 2, we are going on to notes number 5 for this unit on arithmetic and geometric sequences and series. So yesterday we started talking about what a series is. That's taking a sequence and just adding all the terms together and just kind of seeing how that works. Today we're going to look at some formulas for arithmetic and geometric series and how those work. So I asked you to watch another video before you go through these video notes. And that video talked about Carl Friedrich Gauss, who's a famous mathematician, and kind of the story that goes along with him and how he came up with a way to add together a whole bunch of numbers much more simply than sitting and just adding them all together. So hopefully you watched that, because if you did, then this next kind of part is going to make a lot more sense. If you didn't watch that, then you won't kind of understand where I'm getting my steps I'm doing here. So I recommend make sure you go watch it. It's kind of short. You can at least get the gist of what's going on there. So, okay, so in that video, Gauss figured out that he could take, or basically there was a pattern in the numbers and how you added them together. So we see that you can take the first number and add the last number together, and that gives us kind of the length of one side of the rectangle. And then we take the number of terms in the sequence and we divide it by 2, and that's the other side of our rectangle. We multiply those together, and that gives us the sum of all the terms in the series. So if I'm doing that, we have a sum of the first 40 terms of the arithmetic series, 2, 5, 8, 11, right? Okay, so to do that, like we saw in the video, we need the first term, which in this series we know is 2. And then we also need the last term. Well, I'm looking for 40 terms, right? So I would also need the 40th term. Now, this series just has that dot, 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 which means I need to find what is that 40th term at the end, right? So to do that, I can use my formula I know to find terms of an arithmetic series. So that formula, there was our a sub n, is the first term plus the common difference times n minus 1, right? So if I'm looking for the 40th term, then I would take my first term, which is 2, plus my common difference. To get from 2 to 5, I add 3. From 5 to 8, I add 3, right? So our common difference here is 3. And then n minus 1 would be 40 minus 1. Okay, so then I would do 2 plus 3 times 39, okay? And so that would give us 2 plus 117, which is 119. So our 40th term up here would be 119, right? Okay, so then in the video we saw that we take that first term, okay, so we add the first term, plus we're going to add our last term, and then we're going to multiply that by the number of terms, which in this case was 40, but we have to divide that by 2, right? So then to get our sum, I would do 2 plus 119, and then 40 divided by 2 is 20. So that would be 119 plus 2 is 121 times 20. So then our sum of the first 40 terms would be 121 times 20, which is 2,420, right? And when we do sums on series, we use a big S, and then we put our number of terms that we added down at the bottom. So the sum of the first 40 terms would be 2,420, using that method that Gauss figured out when he was just a kid, right? Okay, so using this method that we saw in that video, we can actually come up with a formula for the first n terms of an arithmetic series. And it looks exactly like what we just did, right? This guy right here is technically our formula. The only thing is, normally when we write it out, we see it written kind of the other direction. So you've got the first term, right? And we have the last term, or the nth term. And then our n, remember, is our number of terms that we're adding up, right? So there's our formula to find the sum of the first n terms of any arithmetic series. So remember, this is for arithmetic. On that quiz you guys took last week, I saw a couple people confusing the arithmetic and geometric formulas. So make sure you're paying attention to which formula goes with which type of series or sequence. Okay, so let's kind of do another one of these just to make sure we're able to use the formula okay. I want to find the sum. That's my hint right there that I'm going to be using a sum formula, right, because it asks for a sum. I'm going to find the sum of the first 20 terms of an arithmetic series, whose first term is 8, and then our common difference is -3, right? Okay, so I want the sum of the first 20 terms, and I know it's arithmetic, which means I'm going to use the arithmetic formula that we just talked about. So I'm going to do n over 2 times our first term plus our last term, right? So then we just got to plug in the different things that we need, right? So if I want to find the sum of the first 20 terms, well, there are 20 terms, so I'm going to do 20 over 2. My first term, that's given to us there, it's 8, plus my last term, I don't know yet. So that's the part we have to kind of go off to the side and figure out, right? So to find my last term, for that an, that would be the 20th term, because I'm looking for 20 terms, right? So I want a 20. Since it's, again, arithmetic, I'm going to use that arithmetic formula to generate terms. So I'm going to do the first term plus the common difference times n minus 1, right? So we know the first term, that's 8, that was given to us. And we know the common difference, right? They told us the common difference is -3. And then our n minus 1 would be 20 minus 1. Okay, so that gives us 8. And then we're going to do a negative, so -3 times 19. And then we would do 8. 3 times 8, or 19 is 57. And then 8 minus 57 would give us -49. So our 20th term is -49. And you can kind of think about that, make sure it makes sense. We're starting at 8. We have a common difference of a negative number, so we're decreasing with each term. So it makes sense that we would eventually get to negative, right? Okay, so now I can take that 20th term and plug it in over here. So we have -49. And now to find our sum, 20 divided by 2, that gives us 10. Times 8 plus -49 would give us -41. And then we multiply those. So the sum of our first 20 terms would be -410. Right? Okay, so that's how we use the formula for the sum of the first n terms of an arithmetic series. All right, let's try one with our sigma notation that we talked about in the last notes, right? Okay, so in this one, we're going from the first term to the 20th term, right? Remember, these are your limits of the summation. It tells you where to start and where to stop, right? So we want to start with our first term and with our 20th term. So that means I'm finding the sum of the first 20 terms, right? And first of all, I want to make sure I know, is this an arithmetic or a geometric series? That's important, especially after we get the formula for our geometric. Right? So to do that, I want to actually write out some of the terms of this series, right? So let's actually find some of the terms of our series here. So I'm going to start with the first term, which means I'm going to plug in 1 for k. So my first term would be 5 times 1 plus 2, right? My next term would be 5 times 2 plus 2. And then I would do 5 times 3 plus 2. And then remember, we can skip a few. And I'm going to do the last one, which we're going to stop at 20. So 5 times 20 plus 2. Right? And we can do the math on each of those. So that'd be 5 plus 2, which is 7. 10 plus 2 will give us 12. 15 plus 2 gives us 17. Skip a few. And then 100 plus 2 give us 102, right? So if we just write out the series like we talked about in our notes before, that gives us a few things. I now have my first term. I have my 20th term, right? And now I can look at the pattern, right? So to get from 7 to 12, I would have to add 5. To get from 12 to 17, that's also a plus 5, right? So we definitely have an arithmetic series, and we know then that let's write this down. So it's arithmetic because we're adding each time, and we're adding 5 every time, so that means our common difference is 5, right? Now, I could have just written out the first few terms here to figure out what the common difference was, and then I could use my formula to find terms to figure out what the 20th term was. Instead, I just used that formula that I've already got here to get the first term and the last term. Okay, so now I can go back here to my sum of the first 20 terms, and we're going to do our first term. Oops, sorry. Let's write it the same way, right? I want to do the number of terms divided by 2 times the first term plus the 20th term, or the last term in our sum. Okay, so we're going to do 20 terms, so 20 divided by 2. Our first term we found over here is 7, and our 20th term that we found was 102. Okay, so then 20 divided by 2 is 10. 7 plus 102, that's 109. And then if we multiply that by 10, the sum of our first 20 terms is 1,090. Ta-da! Okay. All right, so sometimes you'll be given the first and last term, sometimes you're given the difference, the common difference, sometimes you're given the summation notation. There's kind of two different examples of how to use that formula for the sum of the arithmetic series. Okay, next, on here on the notes, it has let's develop the formula for the sum of the first n terms of the geometric series. I would normally do this in class, but since we're kind of doing e-learning, I'm going to skip this for now. If you'd like to know how this works, you can look up or Google the derivation. That is a word. How do you derive, right? The derivation of sum of geometric series. I'm sure you're all going to like jump on that right now and go look it up, right? But if you want to know where that formula comes from, that's what you can look up, and I'm sure you'll find a video or something that'll explain that to you. But we're going to skip that for now, and I'm just going to give you this lovely formula. So if you have a geometric series and you want to add up all the terms, we have this formula, right? So the sum of n terms, I'm going to use the first term. That A1, remember, is your first term. And then R is our common ratio for a geometric. And then N, remember, is your number of terms, right? So this formula is a little bit different. In the arithmetic series, we just used our first term and last term, and then the number of terms. This one, we're using our first term and our number of terms, but now we're going to use the common ratio. We don't need the last term. Okay, so let's use that formula to do this first example here. Try to keep it on the same page. Okay, so I want to find the sum, right, of the first 10 terms of a geometric series with a common ratio of 2 and a first term of 1/4. So we've basically got all the pieces here. We just have to plug it into the formula and then solve. Okay, so I want the sum of the first 10 terms. It's a geometric series, so again, that means I want to use my geometric formula. So I'm going to do the first term times 1 minus the common ratio to the number of terms over 1 minus the common ratio. Okay, so if we plug in all the stuff we know, the first term was given to us, it's 1/4, right? I'll make this a little bigger so you can see it. Okay, so 1/4 is our first term, times 1 minus our common ratio is 2. That was given to us in the problem. And I want to raise that to the 10th power, because that's how many terms we're plugging in. That's our n up there, all over 1 minus our common ratio, which is 2, right? Okay, so then just watch your order of operations in the next step. I'm going to put it up here so I got room. So I'm going to do 1/4, 1 minus 2 to the 10th power. Now, this is going to give you a decimal, so you're going to want your calculator handy here. I'm sorry, it's going to give you a very large number sometimes, especially if that common ratio is a little bit bigger. So I'm going to do 2 to the 10th power. That is 1,024. And then I'm going to do 1 minus 1,024, which would give me negative 1,023. Oops, did I write the right number? Negative 1,023 over 1 minus 2, that's negative 1. Okay. Okay, so then 1/4 times 1,023, that gives us a fraction. So I'm going to leave it a fraction. I'm going to do 1,023. Oops, I keep writing 4. Sorry. Okay, 1,023 over 4. If I put that over 1 and multiply, and then all of that is over negative 1. Right? Now, dividing by negative 1, that's just going to change the sign of our fraction. So a negative divided by a negative, that would make a positive 1,023 over 4. Okay, now sometimes you'll want to keep it in a fraction answer, and that's totally fine with me. So I could say that the sum of the first 10 terms is 1,023 over 4. Sometimes it's going to ask you for a decimal answer, or I think on your homework today, when you work on that on Delta Math, it's going to ask you for like the nearest integer, or it's going to tell you to round to the nearest tenth or 100th place. So that's also fine with me. So this one, if I did 1,023 divided by 4, I get a decimal of 255.75. Right? If I was doing the nearest integer, that would be approximately 256, right? Now, only use that if it asks you for it on Delta Math. I am more prone to use the fraction, but I'll also take that decimal answer as well. That's fine, okay? Okay, so geometric series and the formula used for that, right? Okay, let's try another one here where we're just given the series and see what we can do for this. Okay, so S8, remember that big S, that capital S, that means sum, right? So that means I want the sum of the first 8 terms, right? Okay, so first step, if it's asking you to find the sum of so many terms or of a series, always decide first, is this arithmetic or geometric? Because you have to know which formula to use, right? So I'm going to look at my series here, and sometimes even it might be easier to think about it as a sequence. So if you were at 48, then I got negative 24, and then positive 12, negative 6, and so on, right? So looking at that pattern to get from 48 to negative 24, that's dividing by negative 2, right? And then 24 or negative 24 to 12, again, dividing by negative 2. So dividing by negative 2, that's the same as multiplying by negative 1/2, right? So since we're multiplying each time, that is definitely a geometric series. And our common ratio is negative 1/2, right? Okay, so then to get our sum of this series, we now know that it's geometric. So we're going to use our geometric formula. The sum of the first 8 terms. I want to use the first term times 1 minus the common ratio to the number of terms, or 1 minus the common ratio. All right, so when we plug that in, we know our first term, that's given to us in the problem. Our first term is 48. And then 1 minus our common ratio was negative 1/2 to the nth power. So I want 8 terms here, so I'm going to put an 8 there, over 1 minus our common ratio, which is negative 1/2. Okay, now be careful here. And again, I saw this a little bit on the quizzes. Watch your order of operations. This part right here in the middle, a lot of you might be tempted to go ahead and make that, since it's minus and negative, to just change that to a plus. But you can't, because the order of operations here, what I have to do first is I have to do the exponent first. So I'm going to do that exponent first before I do that subtraction. So be really careful there not to pick the wrong thing. Okay, I erased a little too much there. My negative back in. Okay, so I want to do the exponent first here, right? So that will give me 48. And then I'm going to do 1 minus. Now, a negative number to an even power, that's going to end up being a positive, right? And 1/2 to the 8th power is 1 over 256, right? Because 1 to the 8th power is just 1, and then 2 to the 8th power is 256 over. Now on the bottom, there's no exponent, so that does turn into plus a positive. So 1 plus 1/2 makes 3/2, right? Okay, and then I'm going to move over to this side so we have more room. All right, so we have 48. And then 1 minus 1 over 256. Well, that would be 256 over 256 minus 1 over 256. So that's 255 over 256. Right, just doing some fraction math there. Over 3/2. Okay, so then the 48, if you helped, you can put the 48 over 1, right? That 48 and 256 I can reduce a little bit, right? Those are both divisible by, definitely by 4, maybe by 8. Let's see. Yes, definitely by 8. I don't think anything bigger. Nope, I think 8 will work. So let's try that first, right? If I divide by 8 here, I get 6. And then 256 divided by 8 will give us 32. So actually, we could do a little bit more. We can divide by 16. So I can divide again by 2. So that'll give us a 3, and that'll give us a 16, right? So do some simplification of your fraction there. That helps. So then if I multiply across, 3 times 255 is 765. And then on the bottom, we had 1 times 16, that's 16. And that is over 3/2. And remember, a fraction divided by a fraction, that's the same as multiplying by the reciprocal. So this is 765 over 16 times 2/3. So then I can reduce that to 1 and 8. And 765, is that divisible by 3? It is. So that's a 1. And this is a 255. So we will get 255 over 8. Lots of lovely fraction math there, right? So again, if we were doing this like normal at school and we were doing paper quizzes and such, I would have you keep your answers as a fraction. So I'd have you give me 255 over 8 as your answer for the first 8 terms. Now on delta math, again, they may ask you for a decimal or the nearest integer. So if I'm going to do that, 255 divided by 8, I get 31.875, or my nearest integer would be approximately 32, right? Okay, so either of these two answers are exact or the approximately 32 if you're asked that on delta math on your homework. Okay, all right, so there's another geometric. Get into some fraction stuff with the geometric ones sometimes. All right, one more we'll try here. This time with our sigma notation again. So again, remember this is where we start, this is where we stop, right? So first term to the 10th term. I've got my series there, my formula to generate terms. Again, I want to find out, is this arithmetic or is this geometric? That's always your first step, so you know which formula you're going to use, right? So we know we're looking for the sum of the first 10 terms, but I need to find out, is it geometric or arithmetic, so I know which formula to use. So I'm going to write out the first several terms and then get the last term as well, just in case. Okay, so the first term, I would do 3 times negative 2 to the 1 minus 1 plus 3 times negative 2 to the 2 minus 1. And if you've gotten used to the formulas here, hopefully you can tell this one's geometric. If not, that's okay. We'll do it the other way too. 3 minus 1, and I'm going to do my dot, 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 plus 3, negative 2. My last term is 10 minus 1, right? Okay, so that would be 3 times negative 2 to the 0 power. Anything to the 0 power is 1, so 3 times 1 is 3. Negative 2 to the first power, that would be negative 2 times 3. So that would be negative 6. So actually, this is going to be minus 6. Negative 2 to the second power, that would be 4 times 3. So that would be a positive 12. Then we do dot, 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 plus negative 2 to the 10th power, that is positive 1, or I'm sorry, to the 9th power, right? So what negative 2 to the 9th power would be negative 512 times 3. That would actually give us a minus 1,536 for our last term. Okay, so looking at our pattern here to get from 3 to negative 6, that's going to be times a negative 2. And then negative 6 to positive 12 is times a negative 2. So definitely geometric. And our common ratio is negative 2. Okay, so if we go back to our formula, that means I want to take the first term. We know the first term from what we just did, that's 3. So 3 times 1 minus our common ratio, which is negative 2. Don't change that to plus positive yet because we've got an exponent up here. So it's going to be to the 10th power over 1 minus our negative 2. Okay, so then we start doing the math here. So 3 times 1 minus negative 2 to the 10th power. Again, that is to an even exponent, so that's going to end up being a positive, and 2 to the 10th is 1,024. And then 1 minus a negative 2, that would be 1 plus 2, right? Okay, so then we get 3, 1 minus, oops, sorry, go ahead and do that math. 1 minus 1,024, that's negative 1,023. And this one's nice because then those 3's just cross right out and we're left with negative 1,023. So the sum of the first 10 terms is negative 1,023. No fractions or decimals there, so we can just stop at that answer. Ta-da! Okay, so the last part of the notes here, I'm actually not going to go through. This, again, is something we would normally do if we were in school, but with our e-learning and such, we're trying to cut some of the stuff out that is not 100% necessary for you to continue on next year. So we're going to leave this off of me talking through the notes. I am going to actually write these out on the notes so you can see how it works if you're curious. There's no problems on the homework like these, but you never know, you might see it as a bonus question or something in the future. So I will write these out on the notes so you can see how they work, but I'm not going to go through them here on the video notes. If you have questions on those, feel free to ask me. If you see the notes and want to actually know how it works, let me know and I will give you some help there. All right, so homework today again is on Delta Math. Go through to those problems. Let me know if you're having any troubles and I will get to you as soon as I can. Have a lovely day, guys.